I know. One second, give that this here.
Okay, we'll start with the first chapter of geometry, and that is basic concepts. Okay, so at the beginning of this chapter, there is a picture of. Can you tell me what is this image? What are these called?
Pyramids.
Pyramids. Yeah, these are called pyramids. Now, in those ancient old times, the knowledge of constructing these pyramids came from basic geometry. So the Egyptians, they had a tremendous knowledge of how to construct such perfect shaped pyramids. They used simple geometry. So in this chapter, we will be studying the meaning and the definition of basic geometrical concepts. Now, if you see here, if you read at this point in the textbook, they have given you the definition of geometry. What is the meaning of the word geometry? Here it is written, the word geometry itself suggests the origin of the subject. It is generated from Greek words, so it is a combination of two words. First is geo and second is metria. Okay, geo means earth. So see here, geo means earth and metria means measuring. So basically geometry is a subject that developed by measuring earth. So if you see, it can be guessed that the subject must have evolved from the need of measuring the earth, that is the land. So have you got a basic idea of the word geometry, meaning of the word geometry? Yes? Okay, before starting with the actual concept, I would like to explain this last paragraph also. We'll discuss a little bit on this. It says ancient Indians also had a very deep knowledge of geometry. So I don't know if you have heard about the ancient Indian mathematics. Have you heard about it? Anything like this, ancient Indian mathematics?
I can't remember his name, sir, but he invented the numbers.
Numbers. Yeah, yes. That was Bhaskaracharya.
Yes.
If you remember it, yes. But before that, you must have heard about the sacred Indian Hindu texts, that is the Vedas. Have you heard about that, Vedas?
Yes,
now,
sir.
In Vedas, there are numerous other things mentioned, and one of these things mentioned in the Vedas is about geometry. So one of the sacred texts in the Hindu culture is the geometry. And it is explained in detail, in extreme detail, it is mentioned about geometry. If you see, ancient Indian also had deep knowledge of geometry. In the Vedic period, people used geometrical properties to build altars. Now, their altars were their fireplaces. Do you know what a fireplace is? You know, when these ancient sages, do you know who are sages? Who are sages?
Who have great knowledge of
yes.
some.
Yes. Correct.
Who have great knowledge.
Correct. So these ancient sages, what they used to do is in their worshipping used to be around a fireplace. So you know what is a fireplace? Now that fireplace was their altar. So they considered that to be as their altar. And these fireplaces were constructed very beautifully. They had different geometrical shapes and structures. So from there, this knowledge of geometry came up. So they built geometrical property. They used geometrical properties to build these altars called fireplaces. And their book is called as a Sulba Sutras. Okay, see here it is mentioned. Their book is called as the Sulba Sutras, and they describe, and in that book, different ways of and different methods of how to construct those geometrical altars is mentioned by taking proper measurements and all. Now, in course of time, the mathematicians like Aryabhatta, you must have heard about Aryabhatta, Varamihir, Brahmagupta, and Bhaskaracharya, and many of them made valuable contributions in geometry. I don't know if you must have heard about Bhaskaracharya, but Bhaskaracharya's one famous book is also there, and that book is called as Lilavati. In that book, in the book called Lilavati, there are numerous examples, basically geometrical examples of daily life problems. So they are, it's kind of the book is in relation with our daily life. So in daily life, what type of problems you get, that is converted into mathematical forms and explained. So that is a famous book of Bhaskaracharya called Lilavati, and it is named after his daughter. His daughter's name was Lilavati. Okay, so now we can move on to the main part of this chapter. That is the basic concepts. And under that, the first few basic concepts is geometry. The three sub-concepts. One is point. You'll have to understand what is a point. Second, what is a line? In geometry, what is a point, what is a line, and what is a plane? So first we'll start with point. What is a point? Okay, so we'll study point and distances with the help of a number line. Okay, now you must have, you know what is a number line, correct? A number line has integers, and the center of the number line is called as the origin, which denotes the number 0. On the right hand side, you have all positive integers, and on the left hand side, you have all negative integers. Now, if you see on this number line, D, I'm taking a point D. Now, D represents the point. Which point is there for D? Can you tell me?
1.
1. Similarly, E represents the point 3. O, that is the origin, always represents 0. In this, C is for -2, B is for -3, and A is for -5. If you read this here, it says, the point E here it says, see, 1 second. The point E is 2 units away from point D. Understand this first. Point E is 2 units away from point D. How can you tell me it is 2 units away from D?
1, 2, 4.
1, 2. No, you see how many parts it is divided into. So between D and E, how many parts are there? 1 and 2.
1.
Correct? This is one part. This is second part. So between D and E, there are 2 parts. That is why we can say that point E is 2 units away from point D. In simple words, the distance between D and E, the distance between D and E is 2 units. That is the meaning of this sentence here. Point E is 2 units away from point D. Do you understand this? Okay. It means that the distance between, as I said, it means that distance between point D and E is 2 or 2 units. So in the same way, we can find distance between any 2 points on the number line by counting the number of units or parts. Okay, so by the same logic, by the same method, concept, you can find distance between any 2 points on the number line. So for example, suppose I tell you to find out distance between B and E. Okay, distance between B and E. So what you will have to do, you count the number of units or parts between it. So let's count it. 1, 2, 3, 4, 5, and 6. That means the distance between B and E is what?
6.
6 units. 6 units.
6 units.
So using the same method, you can find out distance between any 2 points. So if you see the last point, the distance between, last line, distance between point A and B. So I'll erase this. Now between A and B, that is, this is A and this is B. How much will it be? Can you tell me?
2.
2. So this is 1 part and this is 2 part. So it is 2. Okay, now that was by counting the points, by counting the parts, we could say the distance between these 2 points is so much. Okay, now if you only knew the coordinates, now here we counted in between A and B, you counted the number of parts and you said 2 units. Now, if you only knew the coordinates, what do you mean by coordinates?
Numerical representation of something, of where they are.
Yes. The numerical representation of that point. For example, if you say point A, on the number line, point A is associated with which number?
-5.
-5. So we say that -5 is a coordinate of A. Similarly, B is associated with which number?
-3.
-3. So you say that -3 is the coordinate of B. Now, you can find the distance between A and B if you know the coordinates. Okay, if you know the coordinates, you can directly find the distance between A and B. Now, how that is done? How that will be done? So, okay, I'll take a simple example. Okay, I'll take a simple example. So if you read this, it says to find the distance between two points, consider their coordinates, that means the number which is associated with that point, and you subtract the smaller coordinate from the larger one. Understand this carefully. So to find the distance between 2 points, first of all, you see their coordinates, and then you subtract the smaller coordinate from the larger one. So let's see the coordinates of point D and E. D and E, coming back to the figure. What is the coordinate of D?
3.
D. See on the screen?
Oh, yeah. 1.
1. And what is the coordinate of E?
3.
3. Now, I am interested in finding the distance between DE. So just try to understand this notation. D, distance between point D and E. And then you close the bracket. Is this notation clear, this one?
Yes, sir.
Okay. Now, to find out distance between D and E, you know the coordinates. So you subtract the smaller coordinate from the bigger one. That means you'll do 3 minus 1. Correct? And you know 3 minus 1 is 2. So from here you can conclude that distance between D and E is 2 units, which you can confirm by looking at the figure also. Distance between D and E, 1 and 2. So 2 units. Is this clear?
Yes, sir.
Okay. So I'll repeat whatever we did till now. If you want to find distance between 2 points on the number line, firstly, you find out the coordinates of that point. But that is we have done here. Okay, look on the screen. We have found out the coordinate of the point. Once you find out the coordinate of the points, the distance between the 2 points will just be the subtraction of the smaller coordinate from the greater one. Clear?
Yes, sir.
Okay. Now, let's give you one example. Can you find out distance between, okay, I'll name this point as P and I'll name this point as Q. Distance between P and Q. Without doing the subtraction, just by looking at the number line, can you tell me what will be the distance between P and Q?
3.
3 units.
3.
And now I want to do by subtraction method. So first you find out the coordinate of P. What is coordinate of P?
2.
And coordinates of Q?
5.
5. And then distance between PQ will be what?
5 minus 2.
5 minus 2. And then you know 5 minus 2 is 3, which is same as you get by looking at the figure. So 3 units, 3 parts are there, 1, 2, 3. So distance between P and Q is 3 units. Is this clear?
Yes, sir. Yes, sir.
Okay. Okay. So these two calculations, I'll explain it to you. So the distance between point E and D denoted by D, E, comma, D. This notation, I hope now you're familiar with. Yes?
Yes, sir.
This can also be written as L, E, comma, D, L, E, D. L denotes length. Okay? This here denotes L. So both of these things are one and the same. Okay? D, ED means distance between E and D, these two. And LED means length of ED. So the distance between E and D. So you know coordinates of E. Coordinate of E is 3 and coordinate of D is 1. You do 3 minus 1, 2. Or you can say length of ED is 2. Or distance ED is equal to length of ED is equal to 2. So one in the same thing. You can write any one notation. Clear? Now come to this one. Distance CD. So I'll solve that again and show you. Coordinate of C. Can you tell me what is the coordinate of C?
-2.
And coordinate of D?
1.
1. So I want to find distance between CD. So first, which is a greater number? From these two, which is a
1.
1 minus the smaller number. That is
-2.
-2. And how much is 1 minus -2? Minus into minus.
Plus.
This becomes 1
3.
plus 2, which is 3. That means distance between CD is 3 units, which you can also check by looking at the figure. So C is here and D is here. Count the parts 1, 2, 3. So that means what answer you got is correct. Distance between CD is 3 units. Is this clear?
Yes, sir.
Okay. Now let me give you one other example. Tell me distance between A, B. Distance between A, B. First, what is coordinate of A?
-5.
-5. What is coordinate of B?
-3.
-3. Now, by the definition, to find the distance between it, we have to subtract the smaller from the bigger. Which is the bigger number from these two?
-3.
Yes, -3 is bigger. Minus of the -5. So you have -3. Minus into minus is
Plus.
+5. So you have -3 plus 5. And how much is -3 plus 5?
2.
+2. So distance between AB is equal to +2 or 2 units, which you can also check in the figure. So 1, 2. Clear? Now, one very important
Yes.
note. One very important note. Distance or length. Okay, distance or length can never be negative. Okay, distance or length can never be negative. It was always positive. Correct? Understood?
Yes, sir.
Okay, distance can never be negative. For example, I cannot say I traveled -3 kilometers. This I cannot say. Or you cannot say I live -20 kilometers away from the seashore. This also we cannot say. Distance is never negative. Okay, now since you know distance is never negative, so since we know the distance is never negative, we studied a concept in our first chapter that a number inside that always comes out to be positive. What is that concept?
What, sir? Repeat again, sir.
In the last part of the first chapter, we studied one concept. So that concept goes like, even if a number is negative, after we solve it, we get it positive. We get the answer to be positive. Something with lines, two standing lines. What are those called? Mod, absolute value, modulus, mod, yes. So there is a relationship between mod and distance. Okay, mod, something that gives always positive value inside it, and distance is also always positive, never negative. So there is a relationship between distance and mod or absolute value. Okay, so that line, what I told you, is here. So the distance between 2 points is always positive. That means never negative. Okay, always positive means never negative. Now the last point. Can you read this? If 2 points are distant, what do you mean by distant? Can you unmute and say, what do you mean by distant? Unmute. Distant.
I don't remember the name.
Unique. Same. Not same, sorry. Not same. So what this says that if 2 points are not distant, that means if 2 points are same. Okay, if 2 points are same, then distance between them is 0. Do you understand this point? No?
Not unique. So, what does it mean by not distinct, sir? Then
Yes, I'll show you. So suppose if point C is, I'll not take C, I'll take D. Point D is 1, and I'm saying point P is also 1. That means both these points are the same thing. They are the same coordinate. D has coordinate 1, P also has coordinate 1. So what will be distance between PQ? Sorry, DP. What will be the distance between DP?
0.
0. So you do 1 minus 1 is equal to 0. So if you see, that means distance of this point 1 from itself. Or in simple words, if you want to imagine it, suppose if you are 1, then how much is the distance of you from you?
0.
0, nothing. There is nothing present, so 0. That is the meaning of this last sentence that says, if 2 points are not distant, that means if they are same, then the distance between them is 0. Clear?
Yes, sir.
Now, these two important points, very, very, very important. The first one, as I said, when you're subtracting, you have to subtract the smaller from the larger. Okay, when you're subtracting to find the distance, always subtract the smaller from the larger. And the second very, very important point is the distance between 2 points is non-negative real number. Now, understand the meaning of non-negative. Non-negative means it can be great. It has to be greater than or equal to 0. That means 0 or any positive value. Understood?
Yes, sir.
Non-negative real number means positive number or zero. That means basically never negative. Okay, next is called as a betweenness property. Betweenness. Now, just by the name, as it says, betweenness, so if P, Q, and R are distinct means different. Okay, they are different collinear points. Now, what do you mean by collinear?
They are not in the same line. No, they are in the same line.
They are in the
They are
same
in
line.
the same.
Collinear means they lie on the same line. So now this says if P, Q, and R are different or unique collinear points, that means they lie on the same line, then there are three possibilities. So from there, the first possibility is, this is the first possibility. Point Q can be between P and R. This is one possibility. Q can be between P and R. So from here, we can get one thing. If you see distance, or wait, a distance we'll write later on. If you see PR will be equal to PR, that is this entire segment will be equal to PQ, that is this one, plus QR, that is these two. Correct? If Q is between P and R, then PR will be PQ plus QR. So this we can write it in terms of distance. That is distance PR is equal to distance PQ plus distance QR. Is this clear? First case.
Yes, sir. Yes.
Second, if you see, second, they are saying R is between P and Q. R. Now R is between P and Q. So R is between P. So if R is between P and Q, this becomes PQ is equal to PR plus RQ. Is this correct? So you can write in
Yes,
terms
sir.
of distance. Distance PQ is equal to distance PR plus distance RQ. And the last possibility, the last possibility is if P is between R and Q. If P is between R and Q. P between R and Q. So can you tell me how will this change to now the betweenness property?
R and Q equals to RP plus PQ.
RP plus PQ. Correct. So you have to see what exactly lies in the middle. So in the first case, we had P, Q, R. Now this is a way of writing. This is a way of writing that Q is in the middle of P, or Q is between P and R. Second, we have P, R, Q. So this will say that R is between P and Q. And lastly, we have R, P, Q, and this says that P is between R and Q. So are these three possibilities clear? Betweenness property?
Yes, sir.
Yes. So you have to remember these things. And this is simple addition. So you have to see what is in the between. Okay. Now, based on the betweenness property, first I'll explain and understand this question first. On a number line, A, B, and C are such that distance between AB is 5, BC is 11, and AC is 6. Which of these 2 points is between the other two? You have to tell me which point is between. Have you understood the question?
Yes, sir. So I think A is between B and C.
A is between B and C.
Yes. So
Okay. Yeah. Yes. But how will we show that? For that, you have to remember these things. This. Now, if you note one thing, here Q is between. So you see here you have PQ and QR. So Q is appearing twice. PQ, QR. So same thing here. Same thing here. I'll just write the distances. AB is 5.
Too much is looking for me.
BC is 11. And AC is 6. So you see A is repeating twice, right? A is repeating here and A is here as well.
So all letters are repeating twice.
Oh, sorry, I did not twice. You see the continuation. A, B, and then here it is B, C. A, B, B, C. And then here you have A, C. So looking at it now, can you tell me which is in the middle? Can you try to guess? Or, okay, forget that. Just see the largest number. Which is the largest number?
BC.
BC. So the largest number, that is distance BC, should be equal to the sum of the two smallest number. The two smallest is 5 and 6. So AB, sorry, plus AC. AB plus AC, correct? So let's check if this is satisfying. BC is 11 and AB is 5 and this is 6. So 5 plus 6 is 11. So LHS is equal to RHS, correct? Now here, you see now here, which alphabet is which point is repeating?
A.
A is repeating. So A is between B and C. Okay, so A is between B and C. Yes. The final answer, point A is between B and C. So have you understood? Have you understood what has to be done?
Yes, sir.
So I'll repeat. First, what you do is you take the largest distance, and the largest distance should be equal to the sum or addition of the two smallest distance. So if I take the two smallest, that is 5 and 6, and you add it, 5 plus 6, 11, and that is equal to the largest distance. So if it is equal, then you say that And then you see on this side, wherever you're adding, you see which alphabet or which point is repeated. So A is repeating. So you say that A is in between the other 2 points, that is B and C. Clear?
Yes, sir. Yes, sir.
Yeah. Okay, let's do this one also. And this one, you can help me out in this. I'll explain it to you and then I want you to solve and tell me. So U, V, and A are 3 cities on a straight road. Okay, collinear. Straight collinear, one and the same. Distance between U and A is 215 kilometers. The distance between UA is 215 kilometers. This between V and A is 140 kilometers. That means distance between VA is 140 kilometers. And lastly, distance between U and A is 75. I think this has to be UV. UV. This has to be V. V. Distance between UV is 75 kilometers. You have to say now which city is between the other 2. Can you do this? Largest distance is
B is between U and A.
B is between U and A. Correct. Okay, now this example sum, it is said that the coordinate of point A on a number line is 5. Find a coordinate of points on the same number line which are 13 units away from A. So you have to find 30 units away from A. What are the coordinates? So I'll just draw a rough number line. So this is the number line. And suppose this is the point A here. Point A, and they're saying A has coordinate 5. So they are asking from A, which is the coordinates that is 13 units away. Now, firstly, you tell me 13 units away, will it be on the right side of A or will it be on the left side of A?
Left side, sir.
Left side. Okay. Why do you say left side?
Because 13 minutes.
They are not saying plus 13 or minus 13. They're just saying 13 units away. Distance is given you 13 units. And this, you know one thing about distance, that distance can never be what?
Negative.
Negative. Distance can never be negative. Also, in the question, they are not saying right side of A or left side of A. They are not saying. So whenever it is not mentioned, they are just saying 13 units away. It can be both the sides. No, it can be left side also. It can be right side also. Correct? Now, suppose you are standing at one point. I tell you, move 1 meter away. Move 1 meter away. I'm just telling you. how will you move? Will you move backwards? Will you move forwards? No, no. There are different possibilities. No, you can move 1 meter backwards. You can move 1 meter forwards. You can move 1 meter towards the right or towards the left. So in this case, 13 units away will be on
There will
both
be
the
two
sides.
possibilities.
Yes, two possible. So it can be on the right side also. It can be on the left side also. Now, one thing to note on the if you're moving towards the right, 13 units from here towards the right, 13 units from 5 towards the right, that means you're moving 13 steps. So suppose if this is you're standing at this point. Okay, suppose you're standing at A. And now if I tell you move 13 steps towards the right. So how will you move?
I'll reach 18, sir.
18. 18. And from here, if I say move 13 steps towards the left, where will you reach?
-8.
Minus what?
-8.
-8, correct. -8. So if you see the diagram here, you are standing at this point A here. And from here, if you are moving 13 steps towards your right, so you just add 13 to 5. So 5 plus 13 is 18. And from here, if you move 13 steps towards your left, you'll have to subtract. So 5 minus 13 minus 8. So coordinates can be 18 or -8. Is this clear?
Yes, sir.
Okay, so I think now we can start with the exercise. Now, with the help of the number line, we have to find out the distance. This we can do orally also. Means there's no need to solve, just with the help of the distance number line. So first is distance BE. If you see on the number line, B is here, E is here. How much is distance between B and E? Count the parts.
3.
Number of
3.
1, 2, 3. So distance between BE is 3. JA, can you tell me JA? If you have the textbook in front of you, you can open it and then see in the textbook.
Yes, sir. 3.
3. JA also 3. So 1, 2, 3. So I'll write here 3. Next, PC. P and
7.
C. 7, correct?
7.
1, let me count it. 1, 2, 3, 4, 5, 6, 7, correct. Next, JH.
1.
1, yes, just 1 unit. KO.
3.
3. OE.
5.
5. PJ.
2.
And last QB.
So 7.
7. Yeah. So you can write the answers in the pencil in your textbook itself.
Done, sir.
Okay, now here you have to coordinates of A is X and coordinate of B is Y. You have to find out distance between A and B. And you know this formula, you know how to do it. How do we find distance between 2 points? You subtract the
bigger number from the smaller.
smaller from greater. So if you see the first one, x is 1, y is 7. So distance between AB will be how much? What you
6.
but what you are subtracting
7
from what?
minus.
Yes, 7 minus 1, which is 6. So here you write 6 units. Second one. Can you tell me second one? Which is a greater number?
6.
6.
6 minus 2.
Yes, 6 minus minus 2, which is
Minus
6 plus 2,
plus 2.
which is
8.
8 units. 8 units. Okay. In the similar way, can you solve the remaining all? 3, 4, 5,
Yes.
6 for homework?
Yes, sir.
Okay. Okay. Now, third one, you have to find which point is between which other two. So, first one. So, first one, if you see, which is the greatest number?
10.
10.
PQ.
That is PQ. So, distance PQ, or wait, I'll write it different way. The other two smaller will take first. Distance PR plus distance QR. So that is 7 plus 3. How much is 7 plus 3? 10.
10.
And this is equal to the greater distance, that is distance PQ. So now, can you tell me which point is between the other two?
R.
R, correct. R is between P and Q. So your final statement will be, therefore, R is between P and Q. Did you understand this?
Yes, sir.
Okay, I want you to
Yes,
write.
sir.
I want you to write down this first sum, and remaining other sums also write it in this manner only. Okay, write down this first one.
Done, sir.
Okay, if you see the second one, we'll do this and we'll stop. If you see the second one, which are the two smaller distances?
6 and 4.
6 and 4. That is ST plus RT. ST plus RT. That is 6 plus 4. How much is 6 plus 4?
10.
10. Is this equal to the larger distance?
No.
No, this is not equal to distance RS, which is 8. So it is not equal. So from here, if you get something like this, that is when you're adding the two smaller ones, you're not getting the larger distance. You say that R, S, and T are not collinear. Correct. R, S, and T are not collinear. Write down this sum.
Done, sir.
Okay. So can you do the remaining sum for homework in this third part? Yes?
Yes, sir.
Okay. So you have homework from question number 2 and from question number 3. That's it. We'll stop here for today. Okay. So see you tomorrow.
Bye, sir.
Okay. Wait. Before that, Saturday, 4 o'clock. Are you free on 4 to 5 timing Saturday? Do you have some other class 4 to 5 Saturday? No.
No.
Okay, so tomorrow's class, if I postpone it to Saturday 4 to 5, will that do? It will do?
Okay, sir. Okay.
So tomorrow, instead of 5 to 6, Saturday 4 to 5. 4 to 5. Make a note of it, you.
Yes, sir.
Okay, Saturday, instead of tomorrow, Saturday 4 to 5.
Okay.
Right? Okay. Okay. I'll send a message as well.
Bye, sir.
Okay, bye.